are talking about radicals. This little number outside the radical is called an index. In algebra B, we're not going to do anything too crazy there, so we're pretty much all going to be square roots. We might see an occasional cube root, but that's about it. This symbol is called a radical. And the thing under the radical is your radicand. If you ever see a radical and it doesn't have an index, then we assume it is 2. So if there's no index written, it's a 2. When we do these, we are always finding the positive roots of things. So if I want them, we're going to start today with dealing with squares. So it's helpful if you know what I'm talking about when I say a perfect square. So a square is something to the second power. 1 to the second power is 4, or is 1. 2 to the second power is 4. What is 3 squared? That's 2 to the third. What's 3 to the second? We're looking at perfect squares, so something to the second power.
9.
If I said 4 to the second, what's that? 5 to the second. 6 to the second. 7 to the second. 8 to the second. 9 to the second. 10 to the second. 11 to the second. 12 to the second. Okay, so these are the first 12 perfect squares. It keeps going, you could take any number to the second power. But those are the ones that if you do the square root of, it works out evenly. And we can do square roots on our calculators. So if I wanted like the square root of 121 and I didn't know it, if you hit second, so I have it pulled up here so everyone can see on your calculator, it's this blue button, you have to hit second, and then this x squared, because you see above the x squared there's a square root written in blue. So everybody should be trying this on their calculator. And if I wanted like 121, square root of 121 is 11. It works out perfectly. But not everything does. If I say like the square root of 125, it gives me a decimal. And in general, when we are talking about these, we don't want decimals, so we are going to write them in lowest radical form. We are going to break it down as much as we can, but our final answer may have a square root on it still. So let's take a look. If I say the square root of 81, that is 9. So you might recognize that because 9 to the second is 81. If you didn't, you can do second square root of 81 on your calculator and it gives you 9. If I need the square root of, is there something wrong with that?
Yes,
I can't, 1 second, fix it, please. Alright, if I say the square root of 484, that wasn't on my list, let's see if we know it. So if we hit second square root, 484, what What does that tell me? 22. What is the square root of 64? 8, because 8 to the second power is equal to 64. All right, number 4. It says 18 square root of 4. What that means is 18 times the square root of 4. What is the square root of 4? 2. So 18 times 2, 36. All right, if I say square root of 256, so 3 square root of 256, that means 3 times the square root of 256. What is the square root of 256? 16. So 3 times 16? So if there's a number just outside the radical, but no operation written, we are multiplying. Number 6, this means negative 5 times the square root of 121. What is the square root of 121? Is 11. Negative 5 times 11. Negative 55. Okay. The next few, I put fractions on here. You can do the fractions on your calculator as well. You can type in the square root of 1 over 16. We can also think of it as just the square root of the top over the square root of the bottom. So either way. What is the square root of 1? 1. What's the square root of 16? 4. So this is just 1/4, which is the same thing you get if you just typed it in your calculator. The square root of 9 over 100. That means we could do the square root of 9, which is 3, divided by the square root of 100, which is 3 over 10. Square root of 25 over 49. What's the square root of 25?
5.
And the square root of 49?
7.
So 5 over 7. Are there questions on those? If it is not a perfect square, we are going to reduce it. So we do not want to just give a decimal answer. We are going to find a perfect square that goes into our number. So that divides it evenly. And then we are going to take it out of the radical and reduce. So for instance, if I say the square root of 24, okay, I'm thinking back to my perfect squares. Can I do 24 and divide it by any of these numbers? I can do 24 divided by 4. So I am going to rewrite my 24, and everybody pay attention because I want to see this work. 24 is 4 times 6, so I'm going to write the square root of 4 times the square root of 6. I did that because 4 is a perfect square, and 4 times 6 is equal to 24. What is the square root of 4? 2. Can we do the square root of 6? No, so we just keep it. So this is just 2 square root of 6. So because 6 is not a perfect square, and it's no longer divisible by any perfect squares, we just keep that part of the radical. And you can check on your calculator. I want you to do something. I want you to type in the square root of 24. And it's going to give us this lovely decimal. And then I want you to type in 2 square root of 6. Did we get the same decimal equivalent both times? Yeah. So we can tell those are equivalent. This is just reduced more because we broke down any perfect squares that we could. All right. So 48. I need a perfect square that can divide 48. Some of you might recognize that faster than others. If you don't know it, go back to our perfect squares, okay? It has to be something smaller than 48. Can you do 48 divided by 36? No. 25? 16? Yes. 48 divided by 16 is what? 3. So I'm going to break this into a square root of 16 times the square root of 3. What is the square root of 16? 4. And we don't know the square root of 3, so it's 4 radical 3. Now I want to point out something. 48, is that also 4 times 12? What's the square root of 4? 2. So that's 2 radical 12. But that's not my final answer because 12 is still divisible by a perfect square. I can still divide it by 4. And so you could still get there if you broke your 12 up into a 4 and a 3. It's just longer because I didn't get the biggest perfect square the first time. So we are looking for the biggest possible perfect square so that we only have to break it down once, not a couple times. So if I'm trying to find the square root of 72, I'm going to my list and I think, okay, it has to be smaller than 72. And I want the biggest possible one. Can you do 72 divided by 64? No. 49? No. 36? Yeah. 72 is 36 times 2. So the square root of 36 is what? 6, and then we still have the 2 remaining. So 6 square root of 2. I want you guys to try a few. When in doubt, you go back to your list of perfect squares. And if you need to on the test, you can make yourself a list of perfect squares. We know 1 squared is 1, 2 squared is 4, 3 squared is 9. 4 squared 16. That's the list that we wrote above in that box. But if you are ever confused, just jot this down on the side, and that can help you. When I am looking at the square root of 63, okay, I need to rewrite this as 2 things multiplied together. So I need a perfect square that would divide 63 even. So if it's me and I don't know it off the top of my head, I go to my list and I say, okay, it has to be smaller than 63. Can I do 63 divided by 49? No. Divided by 36? No. 25? No. 16? No. But 9 works. 63 divided by 9 is 7. So I rewrite 63. 9 times 7 is equal to 63. Then we take our square roots. The square root of 9, if you type that in your calculator, the square root symbol goes away. It's just a 3. But if you type the square root of 7 in, does it reduce? No. So my answer is 3, square root of 7.
I flipped mine around.
Oh, you put the 7 on the outside. 90. What could I break it into? 9 times 10. The square root of 9 is 3. 10 is not a perfect square, so it's just 3 square root of 10. If I say the square root of 175, what can I break that into?
25.
So the square root of 25 is 5, and we can't break down the 7. So 5 radical 7. So when it comes out, when you do the square root, it comes out of the radical. If you can't, it stays underneath. All right, let's practice a few more. Once I feel like we've got this, then I will happily stop for the day. 162. Okay, so I need something that I can divide that by that is a perfect square. Can anyone find a perfect square to divide this? 9 works, and 81 works. So there's 2 perfect squares. If there's more than one, we can get there either way. Which one will be fastest? The higher one. So you're not wrong to do 9, you'll just have to break it down twice. If we do 81, it's 81 and 2. So the square root of 81 is 9, square root of 2. If we did 9, it's 9 and 18. Square root of 9 is 3, but 18 can be broken into 9 and 2. So this is a 3 times, square root of 9 is another 3 times 2, and it gives us the same thing. You just have to do it twice. Alright, 245. Something that I could divide that by. We can do 49 times 5. Okay, square root of 49 is 7, and I can't break down the square root of 5, so that just stays. So my answer is 7 square root of 5. The last one, 343.
49.
That's 49 times 7. So square root of 49 is 7. And we still have a square root of 7.